All right, so we're back with another question, or well, at least a series of questions. And similar to the previous video, these questions are not from exams, but they're other revision worksheets of topic one, in which we deal with stoichiometry. And these are questions that may appear to look difficult or tricky, but in fact, they're very easy if you understand the concept. And hopefully, I'm able to make you understand the concept in this video. All right, so let's take a look at the question. So, potassium oxide is used in a closed system breathing apparatus. It removes carbon dioxide and water from exhaled air. The reaction for the removal of water is KO2 plus H2O gives O2 plus KOH. The KOH produced is used to remove carbon dioxide by the following reaction. KOH plus CO2 gives us KHCO3. All right. So the first part, it says what mass of KO2 produces 235 grams of oxygen. So just off the bat, we know that now we're dealing with the first equation over here. The second equation is not relevant to part A. So let's just take a look at the first equation. Now, like I've mentioned in the previous video, in such questions, the very first thing you should do is to make sure that the equation is balanced. If the equation is not balanced, your answer will be incorrect because all your stoichiometric ratios will be wrong. And consequently, you will not get the right number of moles, and then you won't be able to calculate the right mass, so on and so forth. So it's absolutely crucial that you ensure that the equation is balanced. Sometimes in the exams, they give you the balanced equation, but sometimes they don't. So it is crucial that you check that it is balanced. So now let's check, is this balanced? No, it's not balanced. So let's balance it. Now I've already done the balancing so that we save time. Feel free to do it on your own time, just for practice and to check out if you're getting it. If you do not know how to balance it, please let me know in the comments and I will make a video separately for the topic. And I just want to say one thing. If you feel like your question is too small or too silly, please do not feel that way because no question is too small or too silly. I had a lot of silly questions when I was studying chemistry, and my teacher always supported me. And that way, I will also be there to support you just like that. So, any questions, let me know in the comments. All right, so this is the balanced equation with the stoichiometric ratios. Now we can calculate the mass of potassium oxide, which produces 235 grams of oxygen. So first, let's calculate the moles of oxygen. We use the N, or the moles, is equal to mass in grams over molar mass of the substance. So in this case, we know that we have 235 grams of oxygen, and we divide that by the molar mass of O2, which is 32. And that gives us an answer of 7.34 moles. Now you see, oxygen is in the 3:4 ratio with KO2. As you can see by the coefficients over here, it's in the 3:4 ratio. So what that basically means is for every 3 moles of oxygen produced, 4 moles of potassium oxide is consumed or is reacted. So this is very easy. Actually, some students may find this a bit difficult when the ratios are not in whole numbers. But by what I mean is, if supposing the ratio was 1 to 2, then it's easy to find out the number of moles for another substance because you just have to multiply by 2 or you have to divide by 2. But in this case, you're not dealing with whole numbers, you'll be dealing with a fraction. And that is also extremely simple. If you have this type of question, so suppose I need to find out now how many moles of KO2 are used. Just take 7.34, which is the moles of oxygen produced, and multiply it by 4/3. Now, why have I done that? I'll show you why. In order for you to get from 3 to 4, you have to multiply 3 by 4/3, correct? Because these cancel out and then you have your 4. Just in that way, in order for me to get from 7.34 moles, and if I want to keep that ratio between these two, and if I want to follow the stoichiometric ratios, I need to multiply by 4/3. And that will give me my answer of, oh, I can't do this mentally. I need my calculator. So let me just do that real quick. So that will give me an answer of 9.786 moles approximately. Now, it's simple after this point. All we have to do is substitute this value into the n is equal to m over capital M equation, and we will get the mass of KO2 required to produce this amount of, or these many moles of oxygen. So that'd be 9.786 is equal to X, which is the grams, mass in grams of KO2. And we know the molar mass of KO2, and that is 71.1. Let me just double check if that's the correct answer. Yep, that's correct. So it's 71.1. And now just solve for X. So when you do this on a calculator, you'll get your answer as 695.832 grams of KO2 is required to produce 235 grams of oxygen. That's your answer. I hope I've done it well, and you've understood what I've done over here. I have to erase all of this now to make space in order to solve the next part. But if you do not understand, please rewind the video or pause it and see my working. And if you still do not understand it, drop a comment below as always, or message me on my social media, or send me an email, and I'll be more than happy to answer your question. All right, now let's take a look at part B. Now, part B, I'm going to be completely honest. When I was solving this question, it is a bit challenging if you are new to this topic. If you have just begun IB chemistry, you may find it a bit difficult. But trust me, this question actually has less to do with chemistry and more to do with just logic. And let me show you why I say that. So it has asked you, the mass of carbon dioxide can be removed by 100, what mass of carbon dioxide can be removed by 123 grams of KO2? And you may look at this and go, wait, CO2 doesn't even react with KO2. It reacts with KOH. So how am I supposed to figure out what mass of CO2 can be removed by KO2? And that would be a very good question. You're completely right. But these two equations that they have given us in the question, KO2 plus H2O gives O2 plus KOH. And the second equation, which is KOH plus CO2, gives us KHCO3. These two equations, although they are separate, they are linked by one common factor, which is KOH. These guys are linked to each other. So it is actually about logic. So you see that they have given you the starting point over here. They have told you that you have 123 grams of KO2. How much CO2 can be removed using this? But CO2 can only be removed by KOH, and KO2 produces KOH. Do you see where I'm getting at right now? So if we figure out how many moles of KO2 are being used, we can figure out how many moles of KOH are being produced. And if we figure out how many moles of KOH are being produced, we can figure out how many moles of KOH can remove CO2, or well, how much CO2 can that many moles of KOH remove? So come on, let's do this in the question. So I'm going to first balance this equation, of course. The top one is not balanced. I did this in the previous question. I balanced it, but I erased it. So I'm just going to put the coefficients again. This is 2, this is 3, and this is 4. So as you can see, KO2 and KOH are in the 1-to-1 ratio. That means 1 mole of KO2 will produce 1 mole of KOH, or 4 moles of KO2 will produce 4 moles of KOH in context of the balanced equation. But this is the same thing as a 1-to-1 ratio. So first, let's calculate how many moles of KO2 is being used. So we know that 123 grams is being used, and we divide that by the molar mass of KO2, which is 71.1, and that gives us the answer of, I have to do the calculations, I can't do this mentally. So that would be 123 divided by 71.1. That is 1.73 moles. So this means that 1.73 moles of KO2 will also produce 1.73 moles of KOH because they are in the 1-to-1 ratio. So if 1.73 moles are being produced, that means 1.73 moles of KOH can also remove 1.73 moles of CO2. Why? Because KOH and CO2 are also in the 1-to-1 ratio. And just to be clear, this equation that they have given us is balanced. So we don't need to work, or we don't need to change anything in this. And like I said earlier, sometimes they give you the balanced equation, sometimes they don't. So it really depends. But you may be confused about one thing now. You may be thinking, okay, for some reason there were 4 KOH over here, but now suddenly there is 1. How is that possible? Remember, these two equations are independent of each other. They're separate. They are not connected. They are interlinked in one way because the KOH produced in this reaction is used to remove CO2 in the next, but the stoichiometric ratios are not the same. CO2, which is a part of which is a part of the second equation, is not involved in the first equation. And this equation is separate from this one over here. So just keep that in mind. Anyways, so now we know that 1.73 moles of KOH is produced over here, and 1.73 moles of KOH will react with 1.73 moles of CO2 because they are in the 1-to-1 ratio. So now we can calculate the mass of CO2 which will be removed, which is fairly simple. 1.73 times the molar mass of CO2, which is 44.01, gives us the mass of CO2 in grams. And this is equal to 76.13 grams of CO2 will be removed. I hope you understood this part. It is a bit tricky. It will require you to think a bit more or a bit of a higher level than what the usual questions are, but it is all about logic, and I hope you've understood what I've done. If you've not done, shoot me a text, put a comment down below. I will answer your questions. And hopefully you've learned something new. I've been successful in clearing any doubts or questions that you may have had. And I will see you in the next video with another question. Thank you.